Alright, so here we have a nicer presentation of things, right? Instead of just looking at what Dedekind said, it's a little bit more of an analysis, right? So here are two versions of the idealized thing that Dedekind is thinking of, right? U1 includes the perfectly definite number defining the cut, here represented as 1/2. Okay, so U1 includes it, so 1/2 is part of U1 and not part of U2. There's 1/2 right there. It's inside U1. There's U2. U2 includes the perfectly definite number defining the cut, here represented as 1/2. Right? So now U1 does not include it, U2 does. Okay. Dedekind's conclusion is these are the same thing. At the end of it, this is what he concludes. Okay. Regardless of how much closer you look at this is obviously stupid. These are different things, right? Working just from set theory, U2 here is a different set than it is here. U1 here is a different set than it is here. U1 here includes 1/2. 1/2 is a member of the set U1 here and not here. These are different from each other. The fuck are you doing? Anyway, one might note that these cuts are different, despite Dedekind's claims that they are identical. If U1 and U2 are subsets of the rationals, so we're changing things, we're just going to back off from the reals because it's a little easier to conceptualize the rationals, then we know that despite Dedekind's wordplay to the contrary, there are always irrationals which fit between the gaps of any two rationals. Okay. That is, while it's true that there exists a rational between any two rationals, such that if A is greater than C, then there exists some B where A is greater than B and B is greater than C, so B falls between A and C. For rational A, B, and C, this can't ever be leveraged to tell us that the rationals are continuous. Okay? The thing Dedekind is trying to do is he's trying to use this property of the reals to tell us that the reals are continuous. But they operate the same way. Both the rationals and the reals are an Archimedean group. Each one is an Archimedean group. They have this property. And this property specifically cannot be leveraged to demonstrate continuity. Okay? So, for one thing, it specifically means that whenever we find a gap in the rationals, it will bifurcate endlessly into an infinitude of gaps, right? So I find two reals. There's a gap between them. Okay? There's definitely another real between those, or rational, whatever. Some R word that ends with AL. We're using rationals, so I'll try to say rationals right now. Okay, so we've got two rationals. Okay, we can definitely find another rational between them. What that means is now instead of one gap, you have two gaps. And each one of those gaps is going to become two gaps as well, because each one of those is going to have another rational between them. So we're going to get four gaps, and then it's going to double each time. It bifurcates infinitely. So you go from having the problem that there's a gap here to there's an infinite number of gaps here. Okay? One might notice that doesn't eliminate the gaps. It multiplies them. You get more gaps. You get more holes. They're smaller, but there's more of them. Far more of them. Infinitely more of them. And you can never fill any of them. Each gap is an infinite number of gaps. Every time you find a gap, every time you make a gap, it just bifurcates ad infinitum. This isn't continuity. Right? This isn't continuity. Okay? So a far less retarded approach would be to check if we can move from one rational to another without ever encountering something that's irrational, or something that's not rational. And guess what? We cannot. And this means that we can meaningfully talk about the closest possible rational to a given definite rational. Okay? If there's something between our two rational values, for sure, no matter how close that other rational is, that means I can now talk about the closest possible rational to my definite value. Okay? This is something that Dedekind, it never occurred to Dedekind. Okay? So if a is irrational, then 1/2 plus or minus a is also irrational, those two values. By definition, no matter how close the rationals indicated with q's in this diagram here are to 1/2, there must be irrational values 1/2 minus a and 1/2 plus a, which are closer. Okay, so no matter how close this rational is to 1/2, doesn't matter. This is closer. There's an irrational that exists which is closer. This means that our two possible gaps are now not just on either side of 1/2, but there's definitely space. There's space in that cut, and those spaces are different from each other. Okay. Now, if Dedekind cuts are different due to falling on different sides of the reference value, they must also be different by virtue of including different irrationals within the gap that falls between them. Okay? So here is when U2 includes 1/2, right there. The gap here is from this rational Q to 1/2. This is not included in U1, because U1 is only rationals. Okay? Or if U1 includes 1/2, then the gap is here, and U2 starts at this rational. There's a gap which includes this irrational. Okay. Further, we might notice that since there are two different cuts to choose from, multiple values inside the gap made by each cut, and two distinct edges to each cut, is simply ludicrous to assert that the cut is completely defined by one value. Okay? Yes, 1/2 is always an edge to the cut, but that's not enough information to define the cut. Particularly when bearing in mind that Dedekind was ambiguous as to whether the cut in the reals was defined by a real value or simply any value. Read him again. He's not clear on that. So, does 1/2 plus a define a Dedekind cut in the irrationals? I honestly have no idea, but if not, then Dedekind's proof is overtly circular. Okay? So, you might notice if we're going to ignore the width of this gap, then we have presupposed that the category we're working with is continuous. Because we're not allowed to see it. We're not allowed to see the gaps. And if you can think like this, then the natural numbers are continuous. Right? That's what it goes back to. The logic that Dedekind is using, I think, and honestly, this is like throwing him the biggest bone possible because it's the most reasonable way anybody could believe what he's saying. The way he's putting this together implies that the natural numbers are continuous. Because we're just throwing out the gaps between the numbers. And we're only looking at the domain made by the numbers, right? So the domain of the natural numbers is continuous. It goes 1, 2, 3, 4. There's no break between them. It is continuous. It's only when you can see the gaps between them, when you scale, what's the right word? When you extend your numbers? No, because that really isn't right either. Whatever. When you do that, when you move to the rationals or the reals or something like this, that you can see those gaps, that it now becomes discontinuous. It becomes discrete. That's what Dedekind is doing, I'm pretty sure. And if it's not what Dedekind is doing, if he's doing something else, then he's doing something else that's even stupider than that. Because I mean, if you're begging the question or you're posing circular logic, like, that's a normal thing. People make that mistake. But if you're doing something else, then What is it that you're doing? What new level of stupidity did you just stumble upon? Or is this, was he being over, like, intentionally malicious with this? I'm not gonna say that he intended this to be. I think he probably believed it. But it involves circular logic. Like, the best case scenario, it involves circular logic. One way or another, it's either begging the question or it's overtly circular. If it's overtly circular, I think that's the simplest explanation. Alright. So, when we move this over to considering the reals, it's important to keep in mind that all irrationals are real by definition. So the gap-filling values we're interested in must now be something else. Something which is not real. Okay? Infinitesimals are a prime candidate, since by definition they are not real. But this choice brings consequences, as it means that the A in the above diagram is by definition not infinitesimal. Okay? So this gap here that contains values in the rationals, these are not infinitesimal values. These are properly real values that are falling between these rationals here. That's not an infinitesimal. So basically let's get both diagrams on screen. Basically what we did is we just copy this, but we move things over, right? So we move the 1/2 plus a and q over so that they're included in u2. So there's 1/2 plus a and q. They're inside u2. u2 now includes this because this is real. And over here we pushed these over so that u1 includes this. And now the value in the gap, there's infinitely many of them, is 1/2 plus and minus an infinitesimal. And the symbol I'm using that is just the at sign, because it kind of looks like a, but it also kind of looks like an infinity. There's a loop around it. Anyway, that was my choice there for that one. And it's not used by anything anywhere else, at least not very commonly, right? So my previous notation was, it looked like a Lagrangian. Let's not do that. We don't need to make things more confusing. Let's use something rather unique. Yeah. So you have the same problem with the reals. There's gaps here. Unless you're just using circular logic, which says there's no gaps there in the first place, and that's how you're proving that there's no gaps there. Or you're begging the question where you're just kind of like, I can't find any gaps here because I'm not looking for them correctly. So there's no gaps here. Like, okay. I think that's what Dedekind actually did. I think that was what happened, right? But Jesus Christ, if you actually like just think about it a little bit. It's really obvious that he's wrong. This isn't, Dedekind cuts don't work the way Dedekind cuts are supposed to work. Like, this obviously doesn't work. You get an unambiguous hole between these two, and this u2 is different from this u2. And this u1 is different from this u1, even at this level. Even at this level, because, right, we're using axiomatic set theory, right? u1 here is a different set from u1 here. These are different from each other. What the hell are you talking about saying that this cut is the same regardless of which side is defined or not? No. No, at no level is this correct. It just isn't. And for this to be, like, axiomatically accepted by, like, everyone, what the hell is going on? What the hell is wrong with everyone?